Regards, math lovers, and welcome to yet another video of our channel. This time we have selected a problem from Chile Math Olympiad of 2022 for high school students. And the statement of the problem is as follows. Find all the solutions in the set of real numbers for the following system of equations. X plus y plus z is equal to 1, x squared plus y squared plus z squared is equal to 1, and x cubed plus y cubed plus z cubed is equal to 1. As always, if you have a solution to this problem, please pause this video and write down in the comments your proposition for the solution of this problem. We go, without further ado, to the solution that our channel is proposing, and this is a little bit of a, let's say, heavy technical solution, but is nonetheless is a very interesting solution to this problem. So let's go through it step by step together. So as always, we start by making some definitions and observations from the given system of equations. From the second equation of the system, we have that x squared is equal to 1 minus y squared minus z squared. And now, by squaring the two sides of the first equation over here, we will have that. So we take y and z on the right hand side of the equation, and we have that x squared is equal to 1 minus y minus z squared. So we now expand. We substitute the value of x squared with the one that we have from the second equation, and we will have that x squared, which is equal to 1 minus y squared minus z squared, and for the expression on the right hand side, 1 minus y minus z all squared, we now expand and we will have the factors 1 minus y minus z minus y plus y squared plus zy minus z plus zy plus z squared. And now we will take all the values of y and z on the right hand side. We will cancel the terms which are with opposite, let's say, with opposite signs, and at the end we will have that again. We substitute that 1 minus y squared minus z squared is equal to x squared, as we saw from the second system of equations. And now we factorize, and we will have that x squared is equal to 1 minus 2 times y plus z plus 2y plus y squared plus z squared. But from the first set of equation, we have that y plus z is equal to 1 minus x. So y plus z, we substitute by 1 minus x. And y squared plus z squared is equal to 1 minus x squared. So we substitute this value over here, and we will have that x squared is equal to 1 minus 2 times 1 minus x plus 2y plus 1 minus x squared. And we will have, by doing the operations on the right hand side, we will have that 1 minus 2 plus 1, these are terms that cancel themselves. We will take minus x squared and plus 2x, we will take them on the other side of the equation, and we will have that 2x squared minus 2x is equal to 2yz, or that x times x minus 1 is equal to yz. This is a very important result that we reached in this system of equation, and then we call it the equation, let's say, number 1, or the expression number 1, because we will use it in another moment. Now, from the third equation of the system, we have that x cubed plus y cubed plus z cubed is equal to 1, which means that y cubed plus z cubed is equal to 1 minus x cubed. So we can do the factorization, the famous factorization of the third powers, and we will have that y plus z times y squared minus yz plus z squared is equal to 1 minus x times 1 plus x squared. So in this system of equations, by the equation 1, we know that x times x minus 1 is equal to yz, and by this equation and the first two equations of the system, we will now substitute. Epsilon plus z is equal to 1 minus x from the first equation. Epsilon squared plus z squared is equal to 1 minus x squared from the second equation of the system. And from this first expression we got x times x minus 1 is equal to epsilon z. So we now do the substitution, and then we'll have that if you do the substitutions on this expression up here, epsilon plus z is equal to 1 minus x. Epsilon plus z squared is equal to 1 minus x squared, and epsilon z is equal to x times x minus 1. Then this one is equal to 1 minus x, which was the expression up here, times 1 plus x squared. So we do all the multiplying and the factorization needed, and at the end of all these operations, we will have that 3x cubed minus 3x squared is equal to 0. So this means that x squared times x minus 1 is equal to 0. This equation only has two solutions when x is equal to 0 or x minus 1 is equal to 0. This means that we have two possible solutions for the value of x, so x equal to 0 and x equal to 1. We will now find the other factors of the given system of equations with these two values. We start by the value x is equal to 0 in our system, and now we'll have that epsilon plus z is equal to 1, epsilon squared plus z squared is equal to 1, and epsilon cubed plus z cubed is equal to 1. We will square, we will raise to the power of 2. We square both sides of the first equation to get epsilon squared plus 2 epsilon z plus z squared is equal to 1. So from the second equation, we have that epsilon squared plus z squared is equal to 1, and we substitute over here. So this means that 1 plus 2 epsilon z is equal to 1, or that epsilon z is equal to 0. This means that epsilon is equal to 0, or z is equal to 0, or both epsilon and z are equal to 0. If epsilon is equal to 0, then from the first equation over here we get that z is equal to 1. So one triple of solutions x epsilon z will be 0, 1, 0. If z is equal to 0, then from the first equation epsilon is equal to 1, so the second triple of solutions will be 0, 0, 1. If the three terms are 0, we do not have a parity of the system of equation up here, so 0, 0, 0 cannot be a solution of this system. Up to now, we deducted two solutions, which are 0, 1, 0 and 0, 0, 1. We now go to the case where x is equal to 1, and by substituting into the initial set of equations, we will have that epsilon plus z is equal to 0, epsilon squared plus z squared is equal to 0, epsilon cubed plus z cubed is equal to 0, which gives epsilon is equal to minus z, epsilon squared is equal to minus z squared, and epsilon cubed is equal to minus z cubed. But in this expression, epsilon squared cannot be negative. It can be of a minimum of 0, but it cannot be negative. So in this case, we say that epsilon is equal to 0, and also z is equal to 0 from the first equation. So from the second equation, we deduct that epsilon is equal to 0, and substituting on the first equation, we get that z is equal to 0. So another solution, which fulfills the initial conditions, will be 1, 0, 0. So at the end, we say that the full set of solutions in the set of real numbers are the triples x epsilon z, which are 1, 0, 0, 0, 1, 0, and 0, 0, 1. And please tell me on the comments if you like this problem and if you would like to see such problems in the future treated by our channel, so solutions of similar problems. And please write down on the comments if you have another alternative solution to this problem. Thank you very much for your time, and see you on our next videos. Goodbye.